Hi everyone, my name is Amy Wang. I'm a senior solutions architect here at Databricks. I have a background as a data scientist and help my customers and prospects build machine learning models on their existing infrastructure. So today we're going to go over what is a template example of a machine learning model lifecycle. In particular, we're going to be using credit risk or loan risk as our use case to demonstrate what Spark and Databricks and MLflow can do to help you not only track your experiments, but also help put them into production in an easy, iterative fashion. So really quickly today, as an overview, here we go. The outline of today's talk is going to be pretty hands-on. It's going to be less slides and a lot more code and actual demoing. So if there's at any point anything that's unclear, feel free to let me know. I can slow this down. But overall, what we're going to go over in a real-life use case is defining the real-world business problem, understanding what data we have, how we can leverage it to solve the business case that we've defined, how to go through the model training and experiment tracking model lifecycle, and the algorithms that we leverage for that model build, what are the pros and cons, limitations, as well as required capabilities for productionalizing certain algorithms in production. And finally, the deployment stage, how we're able to give you an API that takes a model that you tracked and experimented on and validate it, and how to put it into production, whatever production means for you guys. So in particular, the use case that we're going over today is leveraging a Lending Club data set to do credit analytics. But at a high level, machine learning, for those of you who are not data scientists in the room, it's a way to basically generate insights from data, automating it and creating a robust sort of rules engine that you can put into production to drive business decisions and actually either increase revenue or decrease risk. There are a variety of Databricks customers that either use machine learning models to do customer analytics, to do fraud, threat, or security detection. In particular, we're going to be talking about credit analytics or asset management based off of the risk of each individual asset. Again, I mentioned that the data that we're going to be using today is from Lending Club. So Lending Club is a peer-to-peer lending company based in the US, I think in particular San Francisco. It allows investors, which are everyday people like you and me, to provide funds for potential borrowers and allow investors to earn a profit depending on the risk that they're willing to inherit from taking on the loan. Lending Club provides sort of the bridge between these everyday investors and borrowers. They have the data, which you can get a snippet of it right now on the presentation, is available online and is a public data set. Feel free to download it, ingest it into your own machine learning tools, and try to reproduce what we're going to go over today if you have the time offline. In particular, the FICO credit score is something that we're not actually going to use in this particular demo because it is PII data, and in order to get it, you have to sign up for Lending Club. But you are welcome to do that. It might improve some of the machine learning models that we're going to build as a template today. So for a lot of my customers, the model lifecycle, or for data scientists, the workflow that you're all very familiar with is you have some sort of raw data. And the raw data, you have to clean it. It's coming from your data engineers, or it's coming from a third party that you can scrape off the internet. But you need to clean it, prep it with whatever tool you're familiar with, and then you want to generate features that you can input into a model training process. And the model training finally would then get deployed either to a data engineer or software engineer that would pick up where you left off. At every point in that process, what we typically see, what we typically see is that there's a variety of tools that's being leveraged to to work through and build a quality model. So it's not always realistic for a data science use case for the entire company or even the entire data science team to unify it on a specific set of tools without sometimes sacrificing the quality of the model. So we want the data scientists to be able to use the tools that they're familiar with, try to generate those features or build those models as quickly as possible so that they can iterate through it, understand what are the outputs and how to change it to make the model better. And what Databricks attempts to do is provide a platform that makes it really simple to basically spin up these compute resources, build these training models, and also track the experiment through this process so that other users on the platform can either reproduce it or pick up where you left off, in particular data engineers or software engineers who are sometimes in charge of putting the models into production. So today we're going to work on, in the abstract we talked about basically leveraging some GBM models. So today we're going to be using GBT from Apache Spark's Spark ML as well as XGBoost from DMLC. But there's a variety of different GBMs that are available out there. In particular, a lot of people are moving from single node scikit-learn and R to distributed algorithms and implementation that's widely available. It's kind of funny how there's actually a growing number of distributed algorithms. I haven't even put XGBoost up there yet. So it seems to sort of outnumber the single node implementation at this point. In particular, we're going to, again, use the DMLC's XGBoost and Apache Spark GBT implementation. So Apache Spark, Spark ML or Spark ML lib is a library of algorithms and transformers that's included with your distribution of Spark that you're using to do data transformations, the ETL work, and you can continue to use the power of Spark with this library to essentially build your models in parallel. Everything stacks into a model pipeline that you can essentially export out to disk and re-upload into a Spark cluster to score. Everything that's been shipped in Spark ML, well, not everything, Spark ML or Spark ML has been shipped with Spark since version 0.8, so the longevity of this particular library has been long-standing. We have a number of customers who leverage it to build their machine learning models. Some of the things that are great about using the native implementation of GBT or GLM with Spark ML is that there's no conversion of the data to other data types for different platforms or different frameworks. So in particular, let's say compared to XGBoost, there's no conversion of the Spark data frame to a D matrix. The algorithms themselves are exportable as mleap exports, which could run completely independent of a Spark cluster. And it also natively imports back into Spark as a UDF. So if you do want to continue to leverage a Spark context, it's really easy to import it back to score in a batch or stream. And we'll talk about that a little bit more later. The other competing tool here is XGBoost. Spark ML's GBT and DMLC's XGBoost is, from what I've seen in the field, two of the most frequently used library for GBM. And XGBoost in particular is one of the most frequently used libraries for winning Kaggle submissions. It has been integrated with Spark, so there is a package out there called XGBoost Spark, and if you use leverage Databricks, there is a ML runtime that has it pre-installed out of the box for you to ready to use. The way that it works with Spark is that it converts essentially a Spark data frame, which is a structured RDD, into what XGBoost understands and knows how to process, a data format that it knows how to process that they call a D matrix. It works with auto-scaling clusters. So it's great if you don't know how to right-size your cluster. It still works with auto-scaling cluster the same way that Spark ML algorithms do, and it also works with Spark ML pipelines. So if you want to stack transformers on before actually creating the XGBoost estimator, that's something that you can do and also save out to disk and re-import back into Spark. And finally, the last step that I'm going to demo today is going over the model deployment. So MLflow is what we're going to use to orchestrate this model deployment. What we want, again, like we said, to allow data science to use any ML framework that they're familiar with, or to experiment with multiple ML frameworks, whichever one generates the best quality for the business case. And then what you can do and extend MLflow is to create different flavors of MLflow compatible models that can leverage the same API to essentially deploy this model into production. And into production could mean a variety of different things. I think we often talk about that with our customers. What does production mean for you? For some people, getting a mortgage loan, for instance, and waiting to score until the next day before you get verification of that loan is approved is okay. So you have a daily batch score. But for some people, it's a matter of, it's a credit card, and we want them to start leveraging the credit card as soon as possible. Maybe let's have it scored in 5 or 10 minutes, in which case maybe let's leverage something like structured streaming, which has lower latency than batch scoring, but also a way to basically track all the scores that has been happening and saving it out to a standardized data sync. And then finally, there are use cases where you really want low latency scoring. So this includes in the financial district, in the FinTech industry, scoring, let's say, credit cards. The moment you swipe a credit card at the point of sale, you want it to hit some endpoint or hit some container that's actually on the machines, score immediately, and return the scores back to you in seconds rather than in minutes or daily batch. So those are elements that we're going to talk about today for this particular demo. So with that, we're going to go straight into the demo. And this here. For those of you who haven't seen Databricks before, you must have seen Databricks multiple times at this point today, if you've gone to at least 1 or 2 talks. So I'm not going to go over all the different components of the Databricks platform or the notebook. I'm going to assume that you have some background in how this works. We're going to start immediately off with a notebook that I've generated to build some sort of machine learning model. It's going to go over the data exploration piece. Is going to go into building a machine learning model, evaluating the goodness of fit for all the different models that we built, and then we're going to export it or track it and save it so that we can score on new loans that are incoming, either in batch or streaming. So the business value or the business case here for this particular case is being able to accurately assess the risk of a loan, not just with a credit score, but based off of the historical behaviors of each customer for Lending Club, right? And this kind of applies across the industry as well. You have credit scores, which is generated by TransUnion and Experian and Equifax, but for your particular demographic or your particular demographic of users and customers, are there other additional features that might be indicators of how risky or not risky they are on the platform. And that's what we're going to try to leverage. In fact, we're not going to use the credit scores as I mentioned before. Having an interpretable model as well can help the loan officer use the model in performing a full underwriting as well. So if you can make some of those models more interpretable by leveraging something like GLM, that could actually be a great complement to existing decision makers who evaluate loans today. So that's also something that we're going to talk a little bit about. So the data, as I mentioned before, there's a small preview of this here. There's a full data dictionary available online. But in short, what we're going to try to do is use features like what is the amount that the user is attempting to borrow, what is their income, their debt to income ratio, what is the purpose of a loan? Is it for medical reasons? Is it for home improvement? Is it for debt consolidation? And basically, what is the term? What you'll see is actually term. The length of the term of the loan is a huge factor in whether or not they're more or less likely to be default on the loan. So in my notebook, I'm going to expand out my Jupyter-like Databricks notebook. It's going to go through the first step of basically importing the data set from S3, which are just Parquet files on S3 at the moment, with a schema inferred. So you can see a preview of that data set by using a display function that we have incorporated out of the box for Databricks notebooks. It's going to run a small Spark job that essentially grabs a preview of that data, and that way you can take a quick look. You can see that PII data, like ID or membership ID, has been redacted or eliminated, essentially. Some of the feature columns include, numerics. There's a couple of them out there, let's say, like, actually, this one's pretty cleaned. Yeah, this particular data set seems pretty clean, but sometimes, let's say, interest rate might have a percentage sign, in which case you want to remove it, transform a string column to a numeric column. That's something that you can easily do within Databricks when you're cleaning up the data set. So we're going to do a couple of simple data exploration tasks without writing very much code at all. So one thing we want to look at is leveraging the existing plotting functionality out of the Databricks notebook. I can drag and drop variables or features into what is a customizable plotting field and generate some small insight on like what the data looks like. So in this particular case, you can see the sum of all the loans per grade type. And the grade is what is Lending Club has evaluated as a good or bad loan, and the rate corresponds to some interest rate because of the risk. So you can see the A-grade loans, which has a lower interest rate. There's a significant amount of money that's been lent out to it for A-grade loans since 2012. In total, it's actually $3.5 billion. There are a significant amount of money that actually goes into B or C grade loans. In total, I think this is actually more than $12 billion total. And then the tail end of this, there's a couple of loans that actually never make it through because Lending Club does have some sort of criteria for outrightly rejecting applications. So we're going to clean the data set up a little bit using PySpark. So people who are familiar with using pandas or with using Python, you can use the native PySpark functionality out of the box that essentially runs on a Spark data frame, a distributed Spark data frame. To clean up the data set, we're doing some simple things like in order to rightly build a model, one of the things as a data scientist is structuring the data so that it reflects the problem statement that you're trying to solve. So we can easily build a model across this data set and say, okay, so we have loans that have been defaulted, charged off, fully paid, charged off or fully paid. And those are either good loans or bad loans. But one thing that you have to recognize is there are a lot of loans within this data set that hasn't been completed yet, and we don't know the outcome of those loans. So one thing you have to do in order to actually build an accurate model is to do something very simple, which is to go in and filter out that the loans are not completed. And then we go in and define whether or not a loan is good or bad based on whether or not it's been defaulted or fully paid off. There's a couple of steps that goes through basically cleaning string columns into numeric columns, doing some simple regex for places, leveraging the PySpark to do so. And then we're going to calculate the total amount of money earned or lost per loan because this is closed off. So we actually know including the amount of money that they have paid in interest, or even if they've defaulted, have they paid actually more in interest before the default of that loan. We can actually find out what's the net negative or positive for each of those loans. Another thing that you can do within Databricks leveraging the display functionality is create like a correlation matrix of different features to each other, as well as look at the distribution of each feature. So one thing that I have sort of dragged and dropped in here, and I can drag and drop a couple more fields, but I have a couple numeric values, loan amount, interest rate, annual income. So looking at this, you can see the interest rate is sort of well distributed. There's a bit of skew on one side. Annual income, there might be some data that we might want to filter out because it looks like it goes far, the long tail of which actually goes as far as saying that someone has $2 or $4 million. So immediately you can see that maybe there's some outliers or some fields that are not correctly managed. So you can go back into the data set and filter out for these outliers before proceeding with your models. You can see some correlations. It might be relevant if you're building something like a GLM model. If you have correlated features, you might want to remove one or the other. If they're highly correlated, you definitely will almost surely want to remove them. So this is just something out of the box that you can leverage to sample the data set and build these correlation matrices. Another thing that we can do is, again, use the display functionality to go in and say, I want to group the amount of loans by, let's say, address state. And the plotting functionality comes into play again using the world map display type. And you can tell that most of the loans are actually originating from California or New York City, Texas, because obviously we have a denser population in those states. What I would also be interested in finding out is, let's say I do a similar group by state, and I want to look at the average income across all the states. So again, you'll see that more expensive states like California or New York have higher income, but the amount of loan that's taken out by these states, the average loans actually don't vary that much. And in particular, if you look at the distribution of the percentage of loans that are defaulted in each state, it's not really skewed, other than in states where there's not much loan originations in the first place. So one thing we can take a quick look here, another display functionality, is to group by the bad loans, to organize them or group them by grade as well, and figure out how much money is actually currently being lost or gained in each category. So you can see immediately the A grade loan kind of looks like there's a lot of positives. There's still some loss there, but the majority of the loss is actually happening between the lower end of this spectrum, and in particular C grade loan, which is again kind of understandable because they're sort of resting somewhere in the middle, right? So we want to be able to right size our assets so that we understand the risk that we're taking on and maybe adjust our expected value so that we're getting actually more value, or the probability of earning more is higher by eliminating some really risky loans based off of our models. So after having cleaned up the data set a little bit, this is sort of a preview of what that clean data looks like. We're going to do a quick select. And essentially, you have the net gain per loan across a data set that I think if we look at originally is about, there's about 1.5 million loans since 2012, essentially. If we go down a little more, data has been cleaned up. We basically have the year has been issued, interest rate, revolving utility rates, the length of your credit history, as well as your employment length, whether or not it's been a bad loan or not. This is just a short preview of what that feature set will look like once you've cleaned up the data. And then we go into basically tracking and building some GLM models. So in particular, in this instance, we're actually using Spark ML's GLM. So we're going to build a logistic regression model, binary classification model, whether or not the loan is good or bad, and evaluate the AUC value, which is area under the ROC curve, to sort of verify whether the accuracy of our model is good enough to go into production. So a couple of things that we want to generate in this use case is some sort of ROC curve picture. So we have a simple Python plotting functionality built in, and you can use any sort of single node Python plotting or ggplot functionality that you are familiar with using today. Just collect the result set back into the driver, and you're able to execute as you normally do on a single node Python process. We're going to try to log. What you'll start to see is that there's a couple of functions out there that starts to track and log a lot of these artifacts. In particular, with the PNG file, we want to log it as an artifact on S3. So this is what this function actually does. Going down, we have the grid of GLM models I want to build. Essentially, within the build GLM function, I'm going to change between the number of iterations I want the model to go through, the elastic net parameter, so whether it's a ridge, lasso, elastic net regression, the regularization strength for that for the elastic net param, and then going into it, I'm going to start the tracking. So mlflow.startRun will essentially start there's a Python process that start tracking what you're doing within the notebook in Databricks, and we're going to go in and basically define a pipeline which includes everything from standardizing the data, imputing for missing values, one-hot encoding for the categorical columns, and then building up a logistic regression model with the variable for elastic net regression and regularization parameters. We're going to build it into a pipeline. And then, again, the important part for ML flow in terms of model tracking and reproducibility is to input parameters that we can go in and sort by after. So the important things that you might change by we log as a parameter. So in this case, we want to maybe make it known that there's this arbitrary algorithm is actually a Spark ML GLM algorithm. We want to log the different regularization parameters, and we want to log the model itself. We're going to go in, again, the plot function that we've defined above will log or track the PNG file that is generated for the ROC curve picture to S3, and then we're going to evaluate the F1 threshold so that we get the best threshold for predicting whether or not the loan is good or not, and getting a good balance of true positives and false positives. Then we're going to score and basically log the model metrics. So the model metrics, as we defined before, is the AUC value or the area under the curve of the ROC curve for the training as well as the validation set. So in each cell, what you can see me do here is we're just calling build GLM repeatedly, and then I'm going to basically switch up the different parameters that I can input into it. You can see the models that are coming out. You can see that for, let's say, elastic net or for Ridge, the models are pretty good, but Lasso, which is starting to drop out too many of those parameters, is actually performing fairly poorly. And that same flow that I just went through, we can go through and basically do with GBT. So the GBT, build GBT model, instead will take something like the max iteration, which is the number of trees, and the max step, and it goes through that same process, start ML tracking. We're going to go through and define a GBT classifier with the different parameters that we're going to loop through. We're going to build a pipeline, log the parameters, log the model, score the model, log the metrics. That's it. And this is like a very repeatable pattern across any library or algorithm that you want to use. The great thing about MLflow is that it's just a tracking platform. It doesn't have to be for specific algorithms. I've had customers who built in-house tools themselves, and we can basically build model flavors that wrap those internal models as Pi functions to use in deployment. So it's really easy to go through this. Again, we're just going to call it build GBT, loop through a couple of options. This is a really bad model. It just builds one tree with max depth 5. So really simple, I guess, decision tree, even with only a depth of 5. We're going to go and build a max depth of 10 and 30. And running through this, you can actually see how long each of those model build takes. And for an increasing number of trees, it doesn't seem to be taking significantly longer because we might be reprocessing a lot of the data transformation. And then finally, for XGBoost as well, as I mentioned before, you can use that same data set that's actually sitting on the JVM, and the way that you stack the transformers is essentially the same. I'm leveraging a Scala interface at the moment because the one that's built, the XGBoost package is built out of the box for ML runtime. It leverages Scala. And essentially, we're going to go through the same process, build the XGBoost model, create the pipeline for the XGBoost model, fit it, and then also call prediction and calling the evaluator to look at the accuracy of the model, which is essentially the ROC curve, AUC value. So if we run through this process, what happens is, typically in a data science use case, is you have something in memory. You have the data in memory. You have multiple models in memory. I have a couple of GLM models. I have a couple of GBT models, and a couple of XGBoost models. Once I tear down this cluster, all of that is gone. So we need traditionally to basically export this out to S3 or a database somewhere where we can store what we've done and where are the data artifacts. But because we've been using MLflow, and we scroll up a little bit here and make this a little smaller, there's a little runs button in Databricks, and you can do this in open source MLflow as well. But if I click into run and pop open all the different runs that I just ran, all of that is already tracked for you. So once this cluster goes down, you have the model parameters that you've built with, how well that model did on the training set and the validation set, as well as the model artifacts that we mentioned before. GBT model, for instance, you can see the conda environment that has been saved for the dependencies necessary to score this outside of Databricks. ML model, which tells ML flow what are the necessary environment, as well as where the data actually reside, in which case, in this case, it's actually a pipeline of what you saw earlier, so a lot of string indexing, imputation, and then finally the GBT classifier. But it's a pipeline that you can, using the Py functionality, re-ingest into Databricks to score or export outside of Databricks to score on an application that has a REST API, for instance. So going back really quickly, one thing we can actually do is point into snapshots of the notebooks as well. And this is something specifically for Databricks notebooks. But in addition to snapshotting how well the models did and the model artifacts, we actually snapshot the code as well. So if you change anything in the code, if you can separate it out so that each version of the code is actually only running one particular model, you can go back and see what you changed. Did you set the number of trees to 300? Did you set it to 20? You can go back in time and basically view the revision history and the exact with the exact data run that you were using at the moment. Any changes that you might have made within the code, you can see the diff between the current state and the revision history as well. So once you've done that, what you want to do next is you have all these models in ML flow. Let's go back really quickly. And I know I'm going to try to run through this a little quicker so there's a little time for Q&A. But in ML flow, what we can go through in the UI is look at the model metrics and compare the model metrics. I maybe want to pick the model with the best AUC value on the validation set, for instance. So in this case, it's probably going to be the GPT model that I built. So I'm going to go into my workspace, and I'm creating another notebook. And this could be a Python shell in in PyCharm or IntelliJ that you can do externally outside of Databricks Notebook. But what I'm going to do is go into MLflow, which is basically a database of all these models that's been built and how well they've done. And I'm going to go in and pick the best model. I'm going to pick the best model. It has a unique run ID that I can input to MLflow's endpoint and grab the model representation the model representation in Spark by loading that model artifact that you saw earlier back into Spark. And then all I have to do is grab a scoring table. This could be from S3, it could be from MySQL, wherever your data resides. And I'm just going to call transform on that data frame. And the transformation of that data frame just comes back with a list of predictions, and I'm just going to go in and do a quick group by of the bad loans versus the predictions from the model and calculate what is the amount of money loss or gain from rejecting those bad loans. So in this particular case, we can see that we've lost, the loss is actually $16 million. So by implementing the algorithm or the model in production, we can actually save customers or save borrowers approximately $16 million, versus these are all loans that where we might have otherwise not have caught, but would have happened anyway as well. So overall, there's a net 16 million gain if you're scoring on the original data set that we've trained with. And this is just another more granular view on how to separate out the confusion matrix, essentially. So these are the loans that we're saving 18 million because we predict the bad loans to be true, but we also lose on, let's say, 2.5 million because we predict something to be a bad loan, but it turns out it wasn't a bad loan. So those are things that you have to consider. At Lending Club as well, you have to consider, because it is a startup, you want to reduce the amount of loans that you reject because you want more traction and more applicants on the site. So that's also another factor that you have to take into account before choosing a model for deployment, and it's not just an AUC value. But in our particular case, we're going to simplify the problem and just look at the overall savings by implementing it. And then finally, I want to show you in batch, it looks really easy by re-ingesting the model from ML flow and then scoring it in batch, but you can actually just as easily do this with a streaming use case. And the streaming use case I have here is just streaming from S3, but you can change this to Kinesis, Kafka. If you're using Azure, you have Event Hub. But essentially, we're taking parts of the data messages that are coming in little micro batches, and we're performing that same function that we have saved in the batch mode operation and performing on these micro batches of data as well. So the way that we call that change is the same way. We just call model.transform. The transformation of the data frame, however, it's not a static data frame, it's a streaming data frame. So you're dealing with micro batches, but nothing else changed other than that. So I can actually call a quick write of or read of the data that has changed since the last time I called the structure stream. And I'm going to initialize the stream to pick up new data, score with the existing model, and then write it back out to S3 as a delta table so I can view it. So in that process that just happened, I can actually change it so that it's continuously streaming rather than once trigger, for instance. So I can do that. And it's going to initialize the stream that will try to basically run through all the data before it shuts down. And you also have this sort of neat UI that tells you how long it takes to score, which is, I think, really convenient. And then going back into it, this is, again, another view of that same business value that you gain from implementing the model in production, but now you're dealing with micro batches of the data or subsets of the data. So this is going to be significantly less than what you probably previously seen before. And then the last way of implementing your model, we went through batch. We went through fairly low latency structure stream micro batching scores. The last option is to, the credit swipe point of sale use case, which is I want the score immediately. So in that same way, I can actually go to MLflow and actually deploy the model into an endpoint, a service like SageMaker or Azure ML. In this particular case, I'm just going to run it on my local desktop. I basically called, here we go. I basically called PyFunc serve, which is MLflow endpoint that I can call. I'm going to grab the UUID of what that model that I want to deploy, and the model name, which is GBT in this particular case. And it basically deploys a Flask application that's scoring a Python function, which is the same Python function that you saw me do in structured streaming, in batch. But now there's an endpoint, a REST API endpoint that you can post to and get some sort of probability or prediction back. So this service is running now on the endpoint, and I have another terminal that goes in and just submits a curl command. And the curl command basically asks for scores on two loans, and it comes back with one is negative for being a bad loan, the other one is positive for being a bad loan. So in that time that we just spent doing a submit, it was probably somewhere on the level of sub-seconds for this particular model. So really low latency. You do have to manage the load balance of the throughput that's coming through in terms of all the post requests yourself, but it's certainly possible to deploy really easily with just leveraging the MLflow PyFunc endpoint. So it just needs to know where to pull from, where to serve to, and the scoring latency goes from daily to possibly minutes to now seconds, essentially. And we can actually take a quick look at this. And you can see the loan that was actually not risky was one that's for only 3 years. It's for their mortgage. It's for debt consolidation. This person has a mortgage, but is an individual that's only requesting $10,000 and make about $80,000 a year, versus a person who is scored to be less likely to actually pay up is someone who wants the loan for 5 years, lives in Virginia, also wants to consolidate their debt, but they rent instead of having a mortgage, and they want $24,000 instead of $10,000, and they make about the same amount of money. So based off of this model, we can easily basically give some general idea to the underwriter or even to the applicant to say, out of the box, you're either approved or not approved, and get sort of really quick decisions on the spot. So this is sort of a simple example that goes over how you can leverage MLflow, Databricks, to use any sort of packages that you currently leverage, But certainly for the next step of my demo, what other things I can do is to evaluate things like how long does it take to score with all these different algorithms and libraries. These could be parameters in MLflow. If latency for scoring is really important to you, that's something that you can also test every time you score and track it to MLflow. MLflow could also be a tool that you leverage to basically understand how your probabilities are changing over time. So in that structure stream, you can actually also call MLflow and track basically the accuracy over time. Every single time you're dealing with a microbatch or a batch of data that you're scoring every day or every hour. And as the performance of your model degrades, you can get some sort of notification, or you can build into it a cycle where it goes in and say like, hey, now your model is sort of not doing as well. Can you retrain? Can you send a trigger or some sort of email notification to go in and say, we need to iterate on this again or see what has changed over time? And so those are other components that I think there are other talks that goes over this. But as a next step, I think is what I would probably build as the final piece of that Lending Club model lifecycle demo. So I think I'm right on time right now. I don't know if I have any time for questions, but are there any questions in the room? It's OK if there isn't, but you can also come talk to me after if you have specific questions and you don't want to broadcast them. OK, thank you, everyone.